Today we're going to talk a little bit about limits. So this video is just going to be a brief introduction to the concept of a limit and some examples about it. So what is a limit? A limit is the value L that a function f of x approaches as x approaches c. And this is going to make much more sense to you once we look at some more examples. Now the main thing to remember about a limit is that the limit is not about what happens to the function f of x at x equals c. It's about what happens as x comes infinitesimally close to c. So let's look at how you would write this. You would write it like this. Limit as x approaches this value c of f of x is equal to a value, let's just call it L. So graphically what this would look like is, let's just say this is your function f of x. And if this is x equals c, then as x approaches c, as x comes really close to c, what does f of x do? Well, it approaches this value over here, right here. So this would be L in this case. So now you might be asking, well, what do you mean by approaches? Can't x approach the value from both sides? And the answer is yes. So let's look at a function like this. Say this is your f of x. This is an open dot, by the way. So now, as x approaches it as x approaches this value c from the left, it would go to this value, say L2. But as x approaches c from the right and comes really close to c, notice that at x equals c, it would always be here because this is with a shaded dot. But as x comes really close to c from the right, then it would be L1. So this introduces one of the rules of limits, is that if x approaches c from the left is not the same as the limit as x approaches c from the right, then the limit of f of x does not exist. So let's look at how to write this. So to write the limit as x approaches c from the left, you would have to put this minus sign up here of f of x, and this would equal L2. And the limit as x approaches c from the right, and you would put a plus sign here of f of x, is equal to L1, or this value. And you can see here that because these two are not equal, we can say that the limit as x approaches c of f of x does not exist, because as it approaches from the left and the right, it's not equal. So let's look at computation of some simple limits. So let's say I asked you for the limit as x approaches 3 of 2x squared minus 7. So how would you do this? Well, look at this function. It's always continuous. There aren't going to be any points of x where it doesn't exist, right? So as x approaches 3, we can just see, you can use direct substitution here. It will just equal 11, right? Because 2, as you substitute 3 in, you'll get this. And this in turn will result in 18 minus 7 equals 11. Here you can just use direct substitution. But let's look at an example where you can't just use direct substitution. So limit as x approaches 1 of x minus 1 over x squared minus 1. Now you'll notice if you just try to substitute 1 into this function, you're going to get 0 over 0, which doesn't exist, and you can't get a good answer with that. But let's do some algebraic simplification and see what we get. So you can say that this is the limit as x approaches 1 of x minus 1, and now we can factor the denominator and get x plus 1 times x minus 1. Now you'll notice these two terms cancel out. So now what we're left with is limit as x approaches 1 of 1 over x plus 1. And you'll notice here we can just use direct substitution to get 1/2. So this is called algebraic manipulation. Now let's look at a one-sided limit. So limit as x approaches 0 from the right of the square root of x. So you can see from the right, let's look at the graph of the square root of x. So it would look something like this, right? So from the right, as x approaches 0, well, this function will just go to 0, right? Because it's here. But you'll notice that the limit as x approaches 0 from the left here, it doesn't exist because there's nothing on the left of 0, because you can't take the square root of a negative number. So it only exists on one side. So you can say that the limit as x approaches 0 of this function does not exist. let's just take a look at a more complex limit that you're going to learn how to solve more in the future, but you should definitely know this one because it appears frequently in problems. So limit as x approaches 0 of sine of x over x is going to be equal to 1. Now you can solve this for yourself graphically right now. So if you graph this function and look extremely close as x approaches 0, you're going to find that this goes around 1. And we're going to learn how to do this algebraically later. So now let's look at a theorem for limits. It's called the sandwich or squeeze theorem. Oops, sorry about that. Sandwich, or some people call it, the squeeze theorem. And what this theorem says is that if we have three functions, f of x, g of x, and h of x, and f of x is always greater than or equal to g of x, and g of x is always greater than or equal to h of x, then if limit as x approaches a value c of f of x is equal to a limit as x approaches a value c of h of x, and let's say this is equal to L, then we can say that the limit as x approaches c of g of x must also equal L. Equals L. Now this should make sense to you because let's just look at this graphically. If we have a function f of x and g of x must always be lower than or equal to it, and then h of x is always lower than that or equal to that, then if f of x and h of x come together and equal the same value, let's extend these graphs and say it's around here, then g of x is always going to be either less than or equal to f of x and greater than or equal to h of x. So it's going to be sandwiched or squeezed between these two functions. So at the limit as x approaches c of all of these functions must be the same. Well, that's it for this video. We're going to go into more detail on how to solve limits in the next video.